Hello, my name is Monge. I work at the Digital Fabrication Lab at IICA. And today I'm going to talk to you about specialized spaces for innovation in agriculture in the American continent from the perspective of IICA. And I would like to share with you all the experience that we have had in our laboratory. As I told you before, I'm a technology evangelist, you may say, at ICA Laboratory. I have a background in engineering and innovation, and I have worked as international consultant on patents of innovation and technology management. In the context of global transformation, which is the topic that brings us here today, when we talk about transformation, the main concept that comes to mind is change. And in this context of change, there's a lot of uncertainty. The response, the answer that ICA has to the global transformation and to the disruption and the change we live in is to provide specialized spaces for innovation, and in this case, the Digital Fabrication Laboratory. We have a pilot program, or the pilot laboratory is the ICA Fab Lab, which is located in Costa Rica, and it started as a joint venture between the ICA and the Costa Rica Ministry for Science, Technology, and Telecommunications. Uh, what we look through the ICA Fab Lab is the approach of uncertainty created by this transformation process through a cognitive approach. In the cognitive approach, we have new technology, the context of thinking about the future, processing information, but also this technology interacts with people. We have teamwork, communication, basically new actors that are emerging in this new context. And from the interaction between the technology and people, new systems emerge, new challenge arise, and we need a systematic approach. We live in a time in which we are seeing a lot of unlikely collaborations, such as the case that we see now, the space exploration, for example, being led in the United States by private enterprises, not the government, and is funded by the sale of electric cars, which in turn is funded by digital currencies. So we see a lot of different collaborations. It means that we have a lot of new actors. And also we are constantly bombarded with news about new technology. So we have quantum technology, quantum computing, quantum networks, artificial intelligence, machine learning, quantum machine learning. So in this context of constant change, new technology, and different and new actors, new collaborations, we have emerging new systems, and we have a lot of uncertainties that need to be addressed through the creation of spaces for innovation. In the case of ICA, the answer, as I told before, is the creation of the Digital Fabrication Laboratory. The answer of ICA to this uncertainty and this constant change is the creation of specialized spaces for innovation. What we seek in these spaces is to efficiently test hypotheses under high uncertainty conditions. As we said, we live in uncertain times. There is a lot of transformation, a lot of change, and we need to constantly, under this condition, test hypotheses on the people relations that we said before, on the new technology and the systems that arise from that interaction. So we use prototyping and the generation of prototypes as a tool to test and to better understand these three elements. What we see here is an example that I will share with you later on. And we see here that these two girls are prototyping with sensors, Arduino, programming, sensor for measuring soil moisture. So we use technology as a tool for quickly developing prototypes, and the prototypes is the way in which we can test an hypothesis of the validity of the technology, but also the relationship with people. So we see here One of the prototypes created here in the laboratory was something very simple for creating and controlling water supply and irrigation. It was a prototype that was created during a morning. It was later refined, and it was a few days later installed, as we can see here, in the in a farm where potatoes are planted, and it's already been tested in the field. So here we can validate whether our assumptions about the the technology, and most importantly, if that technology and that solution is pertinent for the people and the communities. So what we are seeing in our times is a paradigm shift in which we focus on the challenge rather than specific solutions. So it is important to understand the challenge instead of just forcing the technology on the people, because as we see, we have a lot of technology, we have a lot of solutions, and long gone are the times in which we could point out a single technology solution for a single problem. Long gone are times in which if you need to dig a bigger hole, you just need a bigger shovel. Now we need a combination of different technology and different partners in order to address the different challenges. We live in a time in which scientific and technological paradigms are changing. Not so long before, time was not taken into account in the study of science, and it was basically because uh, taking into account the time implies a systemic understanding of the universe, and from the systems and time there is chaos, and from chaos we have emergent systems. So we now know that from very simple systems we have a lot of emerging patterns, a lot of emerging phenomena, and that is the new paradigm, to understand that there is not an absolute answer for all the phenomena. We need to understand the interaction of the different components as a whole and work with probabilities. So what we seek with our work at the Digital Fabrication Lab is to provide these spaces in which the interaction of different types of technology and different communities, different groups of people can be studied. We can learn from that. We can infer how the systems interact and how emerging patterns appear. And from that point, we seek to better understand the challenges of society, and specifically agriculture. And one of the most exciting examples that we have is of the projects that we have developed here at the Digital Fabrication Laboratory is the Geospatial Technologies Rally for Women in Agriculture. Is a project and a methodology was developed by the University of Costa Rica, specifically the School of Geography, and we have already worked 3 editions of the rally. Even the 3rd edition took place during the pandemic in a online. It was an online version, but basically what we seek is to provide very basic technology tools to young women that live in rural areas and that are related to agriculture. We know there is a digital bridge between women and men that needs to be addressed, but also there is a bigger bridge digital bridge between urban areas and rural areas. So women living in rural areas are in a serious disadvantage, and we need to attract the women to agriculture. And what better way to do that than through technology? And once again, it's a paradigm of not forcing a specific technology into the people, but to better give them a set of tools, and then let them who live in the communities, who better know the territories, let them be the ones that tell us what are the challenges, tell us what are the difficulties that they want to address, and they will from the set of tools that we provide to them, they will choose the ones that better address those different challenges. We have had a lot of success with this experience. We have had cases in which women have created applications using geospatial technology in which they have, for example, make maps of contamination points in their communities in order to improve the quality of the water resource in their community to the point that the information was available in a website created by the same girls with the knowledge that they acquired during the rally. And right now, for example, the local authorities and the government is interested in getting access to that information and use it in order to generate policy. Also, we have detected a very important trend, can be said, in which we see that women don't not only take the knowledge, the technology that they learn to use here and use it for the project, but they like to share that knowledge. So we see a lot of impact from women going back to their communities and then starting to teach and train the community in all the tools that they have acquired during their experience here in the Fab Lab and in the rally with the University of Costa Rica. Of course, this could not be possible without the methodology that, as I said before, was generated in the University of Costa Rica, but also the voluntary work of the students of the university to not only to teach these different tools, but also to accompany and be a part of the different projects with the different women. And yes, the people and understanding the communities and the interactions and the actors and the potential partners that we see before is very important. But also as a digital fabrication lab, we tend to study and research on different new technologies, as we said before, different new trends on technology and how that technology can be applied to agriculture, to the challenges of the digital transformation. So one of those examples is, for example, the Internet of Things satellite-based applications. During the last year, during the pandemic, we have witnessed that connectivity is not present in many areas of the world, especially in rural areas, and that is where the connectivity is needed if we want to implement Internet of Things projects and networks for agriculture. So one of the solutions, or one of the potential technologies that can be used to generate solutions is satellite communication. So we have been doing testing with low Earth CubeSat constellations, in which a lot of more than 80 small satellites provide coverage of rural areas where there is no internet coverage, and then we can both collect data from sensors in the field, and also we can control and work in automation projects. So, for example, we can have automated irrigation and control it remotely, even if there is no internet. And this technology is beginning to become low cost. So one of those modules, they go for less than a couple of $100. So we are currently researching on that. But as I said before, not because we believe that this is the solution, but because we believe that this is an additional tool for the set of tools that we want to offer to the different people that come to the Fab Lab. But we want to let them explore the different technologies and let them come up with the precise combination of technologies and actors in order to better address the challenges that they face. Another set of technologies that we're currently studying and exploring in the laboratory is, for example, the vertical farming. We've been doing a lot of research on the basic of illumination and the correct use and application of the hydroponics. Together with that, we've been working in the automation of those projects to make them the least human dependent possible in order to make this attractive for urban farming. And also, we have been working on artificial intelligence because once we have these vertical farms automated, what better way to the next step should be to be able to automatically monitor the different plants. In this case, we have lettuce, and from just a picture, let a computer understand what is the current state of the lettuce, if they need to adjust the water, nutrients, and the different parameters, and do all this completely automated. And also, as I said before, we know that connectivity is a challenge, basically mostly in rural areas where all these agriculture projects are planned to be implemented. So we are also researching on edge computing because we cannot rely on cloud computing for artificial intelligence. So we need to work on edge computing in order to perform all the machine learning algorithms on site, close to the point where we are trying to automate all the farming effort. Also, we've been working a lot with environmental monitoring. There is a lot of electronics and very cheap sensors in the market with which you can develop. And also we have developed very cost-efficient weather stations that can be deployed for different projects to collect data on the field, which is really important for many things. We've been developing soil moisture sensors. For example, the women in the feminine rally, some of them came up with very nice ideas of developing soil moisture sensors for grass and cattle management and for a lot of specific cropping. Also, we have been gone beyond just the agriculture applications and move forward with applications more related to environment and biodiversity. So we also have some sensors that we plan to install and monitor forest fires, and in order to generate data and can generate profiles of these forest fires that will help the people in charge of the management and containment of those fires to better perform during the next dry seasons. Also, we are generating sensors for monitoring the temperature in the sand for the sea turtles when they come and lay their eggs in the sand. That's global warming is producing higher temperatures that is affecting the reproductive cycles of the turtles, and the people that the environmentalists in charge of protecting the turtles, they need the data, and we're happy that we can develop really cheap, accessible, and reliable technology with a lot of open source electronics. Also, we have been working in remote sensing, not just the regular remote sensing using pictures from optical sensors deployed in space, but we've been working a lot with synthetic aperture radar, which is a technology that uses electromagnetic waves in order to create image of the ground. This has a lot of advantages and in tropical areas, which is the case of many countries in America. We can monitor areas even when there is a lot of cloud coverage. So, for example, you can see there on the right in this slide, we have some pictures of some areas in Ecuador. Those are areas that the last time that a good picture of those areas from space was taken was like 3 or 4 years ago. You can check that in Google Earth. There is not a lot of data, and the reason is because, well, is the rainforest. So obviously it's raining every day. There is a lot of cloud coverage, and we managed using synthetic aperture radar to detect deforestation in places where there was no optical data. So this is a technology that maybe is not that new, but it is not very known in the region. I personally learned about it during 2-week training that I took at the Korea Aerospace Research Institute in 2016, which I'm very grateful to the people of Korea and the people at CARI and Daejeon for giving me this opportunity to learn not only about this technology, but all different space technologies and their applications. And I want to take the opportunity here to thank you once again and let you know that the knowledge that I acquired there is being put to good use here in the benefit of agriculture. We have pilot projects in flood, detecting flood areas, soil compacting is something that we are exploring, deforestation, as I mentioned before. We have been making a lot of training from different groups, people, not only in Costa Rica, but also in Central American region, Honduras, Guatemala, teaching them how to use this technology and develop prototypes. We also have organized trainings related to telecommunications, and you might say, why telecommunications? What does that have to do with agriculture? Well, as I said before, we have systems that are in an interaction of people and technology. Now, every day we hear more about 5G, about high-speed data connectivity. We have new trends in Internet of Things like LoRa and Sigfox networks. We have a lot of new technologies of satellite communications. We have a lot of advancement in global navigation. It's become a day-to-day use technology. So we believe that we need to learn the basics of this, and we have successfully just finished in these days the first telecommunications training with the help of people from the Costa Rica Radio Amateur Club, learning the basic of telecommunications, once again, in order to better understand the technology, understand the possibilities of interact with people, and what are those new systems that are emerging every day in these spaces of transformation. And finally, I would like to show you that in the Fab Lab, we think about the future. We have done some research thinking in what will be the ways in which food will be produced when the humans settle on Mars. So we have done some research on high protein crop production, which is like really current knowledge, and also how that relate with production with limited resource conditions, which is what will be faced on Mars, for example, by future astronauts, but also is like the reality in many parts of the world right now. So that took place in the Mars Society Desert Research Station in Utah in the United States, and that was in beginning of 2020. And what are the next steps? Well, basically, there is a lot of excitement in the region about replicating the experience of the digital fabrication laboratory in different countries. Right now, we have in Mexico, there is going to be a laboratory which will be specialized in the production of banana. Similarly, also in Ecuador will be a laboratory also focused on banana but with a slightly different approach. Also, we're working right now with the government of the Dominican Republic, which wants to open their own Fab Lab, but this time more focused on controlled environments. And for example, the Caribbean right now, Belize, and also Bahamas and Barbados, they want to open their digital fabrication labs, but in their case, they want agriculture and understand the interaction of agriculture and tourism, because tourism is really important in the Caribbean. And so that will be like the approach. And even we are thinking and working into having a Fab Lab on a ship or on a sailboat, in order to have all the capabilities of digital fabrication labs available to the different countries of the Caribbean, and able to move the Fab Lab or sail the Fab Lab between the different countries. And that was my presentation on a little bit of the experience that we have had here at the Digital Fabrication Laboratory. I would like to thank the organizers once again for the honor and the opportunity to share with you our experience today.